Does that have a number written on it? Okay. So an important thing to realize is that depending on which OS you're using and some other configuration options here, the traffic on the network over here may not be encrypted locally. So for example, if you're making a query to this local DNS server, that query may not be encrypted. That's especially true if you're going to use Windows. If you're using Linux or FreeBSD, it's sort of optional. You can do it either way. So that's just something to keep in mind. This is not going to encrypt everything. It's going to encrypt, for sure it's going to encrypt things that are not on that local subnet. And also note that there are places on the network here in the hotel where your traffic will be unencrypted. For example, on this subnet, on this link going out to the internet, and of course, out there on the internet. So if there's an attacker or an eavesdropper out there, they may be able to see your packets. I guess this slide says some of the things I already said. Also note that using IPsec does not, it's not a firewall. It's not protecting your laptop from, say, malicious people here locally. They still may be able to reach your laptop, send you packets, and that kind of thing. And also note that the primary goal here is encryption. It's not authentication, obviously, because we're giving everybody the same pre-shared secret. So there's, I'm not authenticating individual users here. I'm just mainly interested in getting you to the step where your traffic can be encrypted. I've got a couple slides here on sort of big picture how this is all going to work. Your laptop, which is the IPsec client, is going to create a security association with the IPsec server. We're using pre-shared keys instead of, say, X509 certificates. Your laptop is going to get a secondary IP address, either automatically if you're a Windows XP user, or manually if you're a BSD, Linux, or Macintosh user. And the way you get an address manually is you get one of these cards, which I've given some of you already. If you need one, come on up. You need one? Okay. That's the last one I wrote on. I remember where well, I'm filling in the last octet of the address. The cards have blanks for your primary address and your secondary address. The secondary address you get from me. The primary address you get from the DHCP server. And in the Linux and BSD configurations, you'll need to type in the primary address and the secondary address into some of the configuration files. Okay, so the way this works is packets leaving your laptop will match an IPsec security policy, and that policy, you don't need to know a lot about the details there. It works a little bit differently for the Windows and non-Windows users. Also for Windows users, we're using an L2TP tunnel encapsulation. For Linux, BSD, and Macs, we're not using, we're using the IPsec tunneling features, so there's no other tunneling protocol like PPP or anything like that. But we have to do some tricks to get the packets leaving your laptop to have the secondary address as the source. So for BSD, we use a routing table trick. For Linux, we use source NAT entries. The IPsec server already has proxy ARP entries for all of those addresses. That's already set up, so packets coming in from the outside will get routed to there automatically. This slide shows the IP addresses that we'll be using. Everywhere that you see 192.35.xxx.yyyy, that represents your primary address that you get from the DHCP server. Everywhere that you see 192.35.169.zzz, that's your secondary address. And then on that same subnet, there's addresses for the IPsec servers. One is using Raccoon, one is using IPsec, and there's another address for the tunnel endpoint for L2TP. Any question? Oh.
Why is there different? Why you have different Raccoon and IPsec?
So when I was preparing all this, I found it necessary to use Raccoon with Windows because Raccoon would create transport mode associations, whereas it was hard or impossible for me to do so with IPsec. However, for the others, for BSD and Linux, I found that IPsec made a better server than Raccoon did, so I decided to have both.
Overall, do you recommend IPsec with BSD?
Yeah, right, I do. They both have issues and pluses and minuses, but you know, if you're trying it and you find one doesn't work, you can, well, in theory, you could try the other, except I would have to do some setup stuff probably to make that work. Was there another question? So here's a brief overview of how this works for Windows. I have a number of slides that will go through all the details here in a second. So by the way, if you're planning to sort of play along and do the same thing, the Windows people are up first. You might want to get ready to go through some of these slides. Okay, so and these instructions only refer to Windows XP and not, say, Windows 2000 or 2003, because it's really hard in 2000 or 2003 to do this, and XP has a built-in L2TP and IPsec client that makes it pretty easy. Once you configure that client, it creates a security association, and then it logs in to the L2TP server, and after that, and then it makes an entry in the routing table, so all the traffic will go through that tunnel and will be encrypted by IPsec. For Mac users, you may want to download this program called VaporSec, and there's a URL for that upcoming in the slides. VaporSec is just a front end to Raccoon, so you could use Raccoon directly if you're more comfortable with that. VaporSec does not do everything that we need it to do, so you will need to open up a root shell and do some things like add an alias to your interface and change the routing table a little bit. So FreeBSD is similar because you also need to change the routing table. You need to manually make an add the alias. You also probably need to add IPsec support to your kernel if you haven't done that already, and need to install the IPsec port. For Linux, my instructions are with using FreeSwan, and I sort of started this before FreeSwan became OpenSwan, and I didn't have time, or I didn't bother to download OpenSwan and see if it's similar enough that it still works, so it may not. You'll also need IP tables so that we can add a NAT rule. Okay, so the next section is about 13 screenshots of Windows dialog boxes and whatnot. So anyone who's using Windows, this is what you want to do. The first thing is to open up the new connection wizard, which you can get to by start, all programs, accessories, communications, and new connection wizard. Ready for the next one? So this should be the first screen that you see after that. And you want to select the option that says connect to the network at my workplace, even though you are not at work and you are not connecting to your workplace today. Obviously, then you select Next. If anybody's doing this and I go too fast, just give me a holler, okay? So the next screen, you want to select the VPN connection option. Here you can type in a name for your connection. Doesn't have to be anything in particular. It can be whatever you want. Then at this point, you are to enter the IP address of the IPsec server. So if you can't read that, it says 192.35.169.254. I only put this slide up here because you may want to select the option that says add a shortcut to this connection on my desktop before you hit finish. And then when you hit finish, you should have that little icon right there, or something like that. This screen that's up here is prompting for authentication to the L2TP server. The username can be anything. It doesn't care. The L2TP server doesn't care. The password is passphrase. And as far as the other settings below that, I don't think it really matters what you select there. Okay, so from this point where you see the connect and cancel on properties, you should click on properties, and you'll get this window. There's nothing really to change under the general tab. Under the options tab, however, you may want to increase the redial attempts and decrease the time between redials, and also select redial if line is dropped. Next, you want to click on the Security tab, and this refers to L2TP security and not IP security. And so that's why you need to deselect this button that says Require Data Encryption. The L2TP server here is not set up for data encryption, so and we don't care because IPsec will be doing all that for us. And then after you've done that, you should click on the IPsec settings button there. And it opens up a box where you can type in the pre-shared key. And the key it's down here at the bottom. It's also in the window. The key says, "What is your threat model?" ? So after you've done that, you select OK, and that window goes away. Then you should click on the Networking tab. And at the top, it says Type of VPN. You should select L2TP IPsec VPN. I think in this example, I also disabled, no, I guess I didn't. Well, I may have disabled some of the Microsoft client protocol stuff, but we probably don't have to. Okay, so then we're done with this little properties dialog. You don't have to change anything under advanced. When you close that and go back to that the screen where you type in the username and the passphrase, you select the connect button. You should see a little window like this that says connecting to 192.35.169.254, and hopefully you will get connected and authenticated. It may, in my test, it sort of took a couple of tries. Sometimes it would redial automatically, and it would work after the second or third time. And then once once you're connected, you might get a little icon down here, which you can click on to get the status window that's shown here. So has anybody actually made it this far and gotten authenticated? Yay, there's at least one. Good job.
Not authenticated yet.
You're not authenticated? Is it still trying?
Yeah, it didn't work the first time.
Okay.
I'm trying again.
I'm interested to see if more than one can do it, because I only tested with one box at home. I never did like 2 or 3, so hopefully it works for more than one. Yeah. Is there anybody here that's going to try this on a Macintosh today? Okay, there's a few. Good. So I think that's okay. Does anybody need me to hold on to the Windows way for a while, or should we move on? I think we'll move on. Okay, so you Mac guys, have you downloaded, or do you have a question already? Okay, later. So has anyone downloaded VaporSec yet? You got it? Okay. That's good. Here's some, there's a set of commands which I guess unfortunately you'll have to type these in. I don't have these pre-typed in for you, but you may want to save these as a script and then you'll be able to execute these often.
So EN0 on, well, at least on 15-inch aluminum, that's the wired Ethernet?
Yes. Okay.
Set the alias for wired Ethernet?
Right. Right. Don't. Yeah. That's just an example. Yeah.
Second octet is supposed to be 25?
No. There's 2 typos there.
Yeah, so it has to be for the network, though. It has to be for the appropriate interface.
It has to be for the appropriate interface where your primary address.
We're not doing some sick trick where we're
No.
pretending that it's coming in on EN0.
That's right.
Got it.
Yeah. The friend of mine that helped me with this, I guess we did it on a wired network, and so that's why I took these examples from there. Yeah, the second line, it should say route add. The first address is correct. That's 192.35.169.252. The next address is wrong, and it should say 192.35.164.1. So there's 2 mistakes there. And obviously in these examples, you replace ZZZ with your assigned secondary address.
In general, is there any way to do dynamic IP address allocation using IPsec, or is it just not there? It's not done.
I think it's not done. You can certainly set up the server to accept any address or from a group of addresses, but you cannot make the IPsec server do the assignments. You would have to use like a PPP daemon or something like that. That's one of the things that the L2TP daemon does on Windows, is it hands out the addresses for you. As far as I know, there's no, say, DHCP over IPsec. That'd be kind of cool. Well, I guess that wouldn't work, would it?
There is one that does it. I can't remember what it's
Oh.
called. There's an allocation scheme. Like when you VPN into like most corporate networks, it allocates that.
Okay, like a proprietary solution or something? No, okay. So are the Mac guys ready for this screen? Or are we still typing in route commands? Okay, no response. So here's what the VaporSec screen looks like. And you can fill in the IP address here. That's actually correct. That's correct. That's correct. The shared secret is the same as it was before. It's actually longer than 4 dots. It's what is your threat model. It's the same as on the card that I've given you. Sure. Oh. I thought he was talking to me.
Yeah, there's, no, I would say,
So I guess this is actually what the main VaporSec screen looks like. This is the previous one is the add or edit screen. So when you get to this point, after you've filled in those fields, you want to hit the button that says vaporize. And then it should change to, down at the bottom, it should change to something like Raccoon is running. And then hopefully it's all set up. I don't have any slides after this for the Mac guys, but you can, the way you can test it is the same way for FreeBSD, which I'll get to in a second. Or you can open up a window and run commands like set key -d, or you can run TCP dump and see if you're seeing ESP packets in the TCP dump output.
What's an ESP packet?
ESP is an IPsec protocol type. It's encapsulation service protocol or something. Yeah, payload packet, I don't know. So since the Mac OS way is a lot similar to the FreeBSD way, some of this stuff will be sort of relevant to you guys too. So are there any FreeBSD or general BSD users here today? Okay. You got your kernels configured already? Cool. If not, you could add these lines to make a new kernel. Here's some commands for installing IPsec from the FreeBSD ports system. And if you don't have the ports set up, you can probably download this binary package from an FTP server. You guys got IPsec already too, I guess? Okay, so on that HTTP server that we thought might be down, there's a file you can download. There's like a template IPsec configuration file that you can download at this URL. You can save it anywhere, but here's the default location: user local etc IPsecD, IPsecD.conf. After you download that file, you need to set your primary address and your secondary addresses. If by some chance you get a different primary address from the DHCP server over the next few days, you would have to go in and edit this file again and change things and restart IPsec because it'll get confused otherwise. Hopefully your address really shouldn't change, but it might if you deleted the state file or something like that. Here's a little startup script. You can also download this from that same directory and just change the variables to match your configuration. The first thing it does is kills any previous incarnations of IPsec, and it flushes the security association tables. Then we add the alias to the interface. Again, this one says FXP0, but likely it's going to be different for you, especially if you're using wireless. Then there's 3 routing commands, one to add a host route, one to delete the default route, and the third to add a new default route pointing to your secondary IP address. Then you start the IPsec daemon. The -4 here says only listen on IPv4 address sockets. That just prevents a little error message from showing up about IPv6. So in theory, after you've gone through those steps, you should be associated and you should be able to see traffic going out. You can run TCP dump in one window and try pinging something in another window. You should see the kind of stuff that's shown here at the bottom where you see these ESP packets going back and forth. You can also run the set key command to dump the security associations, and you should see 2 entries there. How's it going, FreeBSD guys? Any luck? No comment. Well, hopefully, it feels like we're going to have extra time, so speak up if you want some help or some questions or something about that. No? Well, it shouldn't affect.
Think it's running, but I can't ping all.
Did you can you run set key minus capital D? I guess, yeah.
Like a script error, right? And failed our configuration file.
Oh,
I'm guessing each paper set put a bad config file somewhere. This seems, I mean, yeah, I can run set key dash.
does it show anything?
Yeah,
It's got a couple of entries.
got a couple entries, neither of which seem to have anything to do with.
You should see,
One of these should at least have my secondary address in it, right?
it should have your primary address in it, I think. If you run minus DP, you should see your secondary address.
From my secondary address any to 0 any out IPsec, get all stuff.
Is anybody going to try this on Linux today? Okay, good. Oh, I have instructions in the slides for doing Raccoon on BSD, but I think I'll skip those for now. They're kind of short anyway. One thing to note about Raccoon is that it doesn't initiate the security associations until you have traffic to send out. So you wouldn't see anything in that database until you ping something or something like that.
This is
But-
all IP layer, right?
Yeah.
I mean, if I send ICMP out.
Yeah, yeah, that should,
Getting pings back from machines that I know I can ping.
yeah. Okay, these, so when I did my little tests and everything on Linux, I was using Gen 2 Linux, and I didn't have to change the kernel. It was already configured for IPsec. I don't know if all your others will be configured or not, but I think these are the things that should be enabled in the kernel. FreeSwan is the software that I'm using. And I realized later that it's, I believe FreeSwan includes kernel patches, right? So you may have to, after you download that, you may have to apply the patches and then build a new kernel. I sort of skipped over that in the slides. That same local HTTP server has some templates for the Linux configuration in the Linux FreeSwan directory. There's a file called IPsec.conf, which you need to download and change the X's, Y's, and Z's to match your primary and secondary addresses. The pre-shared key goes in its own file, etc IPsec, IPsec.secrets, and it has sort of an interesting format here with the two addresses, then a colon, then the word PSK, and the secret goes in quotes. We've only had one success so far, Susan.
Oh, we should have set up a series of prizes.
Oh, that's a good idea.
There's no time for that. Free internet connection in the meeting room.
Dwayne, I'm curious, you've run through this a number of times. I'm wondering what types of failure scenarios have you found, configuration issues and such?
One of the hardest things was when I spent a lot of time trying to get Windows to work with IceCampD, and it was really frustrating because Windows didn't give you a lot of debugging and that kind of stuff. And it turned out the problem was that Windows needs to use tunnel mode, or needs to use transport mode, IPsec, and IceCampD doesn't really like transport mode. So once I switched to using Raccoon, that became a lot easier. After you get things running, the most common problem seems to be that you get sort of a inconsistency in the keys between the two ends. So for example, if you killed your daemons on your laptop and started it up again, you would make another association with the other side, and then the IPsec server may have two associations in its database and you only have one, and it may be using the wrong one to send packets. Or so one side would maybe time out the key and the other side would keep the key around and think that it's still valid, and those sorts of problems can only be fixed by like restarting one or both of the ends. So
In the debug, you need to see both sides.
yeah, well, it depends on where the problem is, I guess. But other than that, I haven't seen any real significant problems.
Did you try doing multiple connects and disconnects to make sure that you didn't have to go touch the server?
Yeah. Yeah, that works pretty well. Actually, ISACAMP-D, I know when you shut down the ISACAMP daemon, it will send a message to the other side saying, I'm shutting down, please delete these associations, so that when you start it up again, there won't be that other one there still.
What if you kind of close your laptop and it goes to sleep?
Then I don't know. I didn't try that. Yeah, if one of the sides just stops talking, I don't know. Okay, Linux. Oh, you got a question? Yeah? Okay. We'll have to look at that. Unfortunately, I don't have a network connection here, so I can't log in right now. But
I do, can I?
no, I would need to log into the IPsec server over there in the other room. Do you have SSH client on your laptop?
Yeah.
Oh, okay.
Check them up there?
Yeah, maybe I can use it.
Do you have any idea what's error 789 means?
No, but I think when I Googled for those, something meaningful came up, so, yeah.
Or it's too late to reinstall that. Did you find the client? Sorry. Yeah, the easiest thing would be. Yeah. No, I don't think you want. I've got a better one.
Previously working with IceCamp.
Okay,
The one thing I had to do that you didn't mention is to make sure that the IceCamp.com is not globally readable.
okay,
So I changed the permissions from one night in my master to the same file.
right.
Otherwise, we don't do anything else.
Okay, so what Sean just reminded me was that ISACAMP-D is picky about file permissions, and it ignores your file if the permissions are too promiscuous. And so you'll have to change it to be like mode 600 before it will obey. But Sean says he's got it working for FreeBSD.
Can you just SSH from right there?
Yeah, you might be right. It may be only working for one person at a time so far, so we'll have to look at that a little bit later, I guess. Okay, so I'll resume the Linux thing here. By now you should have this config file downloaded and the pre-shared secret file set. Then here's a script which you can also download so you don't have to type all this crap in. After you download it, you'll have to change the Z's to match your secondary IP address. This script adds an IP alias. It adds some things to the NAT tables. It also adds a route. Then it starts the IPsec server, or IPsec client. This script has a little variable which you can set if you want to attempt encryption of the local traffic as well as the remote traffic. So the danger is that if you do that, if you say that you want to encrypt the local traffic and then the IPsec stuff doesn't start up, you won't probably be able to talk to like the DNS server, the local DNS server, and those other things until IPsec starts working. So what I recommend is first get it working with that variable set to no, and then if you're brave enough, set it to yes and give it a try. Again, after you've done all that and run the startup script, you can run TCP dump and ping, and you can check syslog for errors. You can run the command IPsec look, and it should show you security associations, and I think it also shows you routing table for good measure. So after you've gotten all this working, there's a couple things to think about. One of them is MTU sizes. When we're doing all this encapsulation, especially for Windows where you've got IPsec and then PPP and then L2TP, you're adding all these layers onto your packets, they're going to get bigger than the Ethernet MTU size. So you may want to, Windows may be smart about this and do it automatically for you, I'm not sure. And then the Linux and BSDs may be smart too, but you may have to also manually lower the MTUs so that the encrypted packets don't exceed the MTU size. You can sort of test this by running TCP dump and doing a large flow data transfer. And if you see a lot of fragmented packets, and if you care about that, you may want to lower the MTU so that you don't have so many fragments going out there. It probably makes it a little more efficient that way. As I mentioned a little bit earlier, key lifetimes can sometimes be a problem.
That fragmentation is only going to happen if new discovery fails, right?
I guess, in theory. I don't know.
You have to,
No guarantees by me.
on BSD, you have to turn on MTU discovery by default.
Okay. That may be some of the problems I was seeing then.
Otherwise, it won't try.
Okay. Each of these IPsec clients probably has its own values for key lifetimes that it's willing to use, anywhere from minutes to hours. Every time the key expires, it has to renegotiate a new security association. So short lifetimes may be problematic because it may time out, then it may not get a new one for a few seconds or a minute or something like that. And during that time, you won't be able to talk to anybody. Longer key lifetimes are better because there's fewer renegotiations, but it makes your packets a little bit more susceptible to being cracked, or someone could do like a brute force attack or something and decrypt your packets. That's the end of my slides. So at this point, we should probably look at specific problems that people are having, or error messages or anything like that. You got one?
Well, 789, I was getting an error of 789.
Right.
And it was because Windows decided not to start up IPsec. So if you just go into services, it'll start up.
Oh, you have to go to the services
Right.
list and start it? Okay.
So it looks like it's trying now, but it's still not.
Okay, but you're having the same problem
It
as,
looks like it's just timing out now.
right.
Are you getting an error out of it? I was seeing error 619.
Hold on a second.
That's a minus 19. running on the server side
The server runs FreeBSD.
for everybody?
Yeah, the one that server runs both the Raccoon and IceCamp daemon on two different addresses.
619.
Okay, my guess is that there's a problem with the L2 TP configuration on my side, such that it's only giving out one address at a time or something like that. So I'll need to look at that more closely. Anybody else have any successes or failures to report at this point?
So that would affect only the XP users?
Right. Both of these guys are the XP users.
Yeah, that's what I'm looking at.
Pardon me? Not Windows people, I don't think. Oh, there's. Okay, you may be the only one though. Is there another? Okay. Can you tell what address you got? Let's see. So if you're a Windows user, and if you get connected, I'd be curious, when you go to the properties or the status, whatever it is, of the connection, see if you get anything besides 130 in that last octet. If you get 130, then that means that it's only giving out that address and it's not giving out any of the others that I thought I told it to give out. So, okay, so everyone's sharing that address. You get it for a few seconds at a time. Yeah. Okay. I don't know if you have any choice. It sounds like somebody can take it away from you, since there's one, passphrase for everybody. So, so I'll need to go back to the server and look at that closely. Any other questions at this time?
Is this something we're supposed to be able to use tomorrow?
Yeah. Well, I mean, so obviously this is the first time we're trying this and we're working out the bugs, but the idea is that, yeah, it should be up and available for the rest of the meeting and maybe, hopefully future meetings. So.
Just looking at the Windows instructions here, this is not anything you want to ever show to an end user. This procedure of going through all these steps is typically, how does this get handled? Does it get scripted? I mean, what if commercial products don't do this? I can't believe.
My guess would be that if this is not your way, then you're going to pay someone for an IPsec client, and maybe you're going to have like an IT admin who's going to pre-configure things for you, and then the user won't have to worry about it.
I see. So there is a way to buy your way out of this.
Well, even with this, you could have it pre-configured by an IT admin, and then all the user has to do is pop it up and say connect.
Sure.
So once it's once it's set up, it's set up. But if you think this is bad, you should try it on Windows 2000. Because you have to do the IPsec part yourself. You have to go to all these screens. It's like 30 or 40 screens.
But the only real problems you've uncovered today have been with Windows.
Well, I think so. Sean's got it working on FreeBSD. I don't think we've got any Mac successes yet, and I haven't heard from the Linux guys yet either. So.
I also got it working on FreeBSD. The only thing I'm noticing is that when I ping certain hosts, I get sometimes get duplicate packets back.
Really?
When I look at the TCP out, they're all encapsulated. They're all connected.
Okay.
I have no idea.
I've seen that with my wireless card sometimes. That may be that, but hopefully somebody's not crafting IPsec packets that are valid and reaching you.
Because it's a shared passphrase that everybody knows, the key is the key still generated randomly so that while you're encrypted, you're not safe from anybody else who was in this room?
I believe so. Yes. The keys for encryption should be uniquely generated. The problem with the pre-shared secret that we're using is that if you decide to use the same secondary address that I'm using, you can probably knock my security association out and take over. Not that you'd be able to see my packets, but you can just disrupt the service for me.
Kill you.
Yeah.
This could also masquerade as a server, sit there and proxy everyone else's connection through, and then sniff their traffic that way. As little
Yeah.
And the way you can wiretap somebody else's IP negotiation so that you could get their keys and then use those keys to decrypt all their traffic. So
Okay, so it's,
you have to put more effort in.
right,
But you could basically do it by eavesdropping.
okay.
Would there be a mechanism to upload, like use the public key, just like a generated RSA keys, and upload your each person's public key onto some website, and then do the negotiation?
Well, all
I
these,
don't really know how well that works.
all these daemons also have modes where they use X509 certificates. So, you know, that may be that's probably a better option. It's just I didn't want to go through the trouble of doing that for everybody this time. But you could get a unique certificate from me, and then I assume that that certificate can also have things in there like the address you're supposed to be using, maybe, I don't know.
Well, what he's suggesting would probably, if it wasn't too hard to implement, where it's, I could take my certificate, give you my public key, and then you can encrypt traffic to me.
Yeah. I haven't read anything like that, but I guess it doesn't mean it's not possible.
Would it normally assign IP addresses starting at 130 and go up by 1?
For Windows, yeah. That's what it was supposed to do.
Okay, it looks like 129 has something responding to thing.
That's the router.
30, and then nothing above 130.
Right, okay.
I'm actually, just to update on the Duke thing, I'm getting dupes when I ping the local web server, the local squid proxy, which is not going through the IPsec, so that's some artifact of the wireless.
Okay, yeah, that's what I've seen too.
So we can try and experiment, have Windows person disconnect and see if someone will get in.
Yeah, you could. I assume that, you know, you didn't disconnect, right? You did disconnect earlier. Okay. Yeah. I don't know if you have to disconnect and then it releases, or if someone can take it away from you. Okay. Yeah. Unfortunately, there's no way to like manually assign those addresses like there's, you know, for like these little cards that I give out. So we'll have to figure out what the L2TP daemon is not doing right. So I think, oh, go ahead.
There's also at least nominally LTTP support for Mac OS 10
Oh,
and
a daemon level, like a daemon or client?
client.
Oh, client, okay.
So would that be another thing to try?
Not at the moment it wouldn't, but in the future, yeah. Yeah, that would solve one of the problems of giving out the addresses, definitely.
So
It makes it's a little bit annoying because it makes the packets a lot bigger too. You have all these extra encapsulations, but
the addresses that are the 130, is that the tunnel point address?
yeah.
Tunnel endpoint or the IPsec address? Or is that?
Well, the way it works in the Windows case is it sets up, it uses the L2 TP daemon, and then it sets up like a PPP tunnel, and Windows encrypts everything that goes over that tunnel. So
130 is your end of the tunnel.
it's really a tunnel address. It's not really an IPsec address, because in this mode, the IPsec is being used in transport mode, whereas for the Unix guys, it's being used in tunnel mode. So I think the next thing to do probably is to go look at that server and see what's wrong with it. And then if you guys have any, you know, questions, feel free to come by or stop me in the hallway or whatever and look at specific problems. I'll certainly be available for the rest of the meeting. I can.
You can ask embarrassing questions around 9 tomorrow morning, because Dwayne's going to be talking a little bit about IPsec.
Yeah, I have to stand up again and talk about this. So.
Yeah, so if you have any questions, something Dwayne
Or do what Sean suggested and hack the system and steal someone's security associations and embarrass me. Okay, whatever.